Dear students, now we are going to discuss what are the common types of probability density function. So there are numerous probability density function commonly used in both radar, sonar and communication systems. So for example, if you want to analyze the noise spectrums or the noise distribution, normally we will use the Gaussian process. A similar way, here also, we have some common types of probability density functions are available. So what is this probability density function? To describe the characteristics of the receiver noise and the arriving signals of multipaths and the distribution of phase, envelope and power of arriving signal. So the statistical analysis in the signal processing technique, we are using this probability density function. We cannot predict by our mind calculation. So for example, if you want to design one weather prediction model, we cannot use the mind calculation for predicting something. So for that, it needed of statistical report or statistical analysis. So in that wireless communication also, we are introducing this statistical analysis to estimate the parameters of the receiver noise and the arriving signal for multipass and the distribution of the phase, envelope and power of arriving signal. In practical, there are no direct path between transmitter and receiver. So only that's free space propagation only. We have direct line of sight between transmitter and receiver. So in practical, there are no the line of sight in direct way because suppose if you are taken that prediction model for some urban area, so in between your transmitter and receiver, because if you want to make some call to some person, so you are the transmitter and who receive the call, they are the receiver. So in between the sender and the receiver, there might be the large storage of building, large trees, so like that in between the transmitter and the receiver, there are large obstacles are present. So due to that, the arriving signal from the multipath, it occurred of distribution of phase or envelope. The envelope is nothing but shape and the power of the arriving signal. Okay. So to avoid that or to characterize this receiver noise, arriving signal of multipath or distribution of the phase, we need to analyze based on the situation. We are describing some probability density function. So here we have list out the six probability density function. The first thing is Gaussian probability density function, second thing is Rayleigh probability density function, and next thing is uniform, followed by exponential, followed by Bayesian and followed by Laplace. So now the first thing we are going to discuss about that Gaussian density. The Gaussian or normal probability density is perhaps the most common PDF because in your basic classes also you have learned about this Gaussian process for noise distribution. The same thing only here also we are going to analyze. See here the Gaussian distribution generally defines the behavior of noise in receivers and also nature of the random amplitudes of arriving multipath signal. So according to the central limit theorem, the sum of numerous continuous random variables as the number increases tends towards Gaussian distribution. So now here mainly this Gaussian distribution define the behavior of noise in the receiver and also random amplitude of arriving multipath signal. So what is the probability density function formula? P of s equal to 1 divided by root of 2 pi sigma square x minus x naught the square divided by 2 sigma square. This formula derived based by Gaussian process. So based on the standard values of sigma and also the mean value is nothing but x naught here. Mean values means average values. So x naught. So based on these two parameter, we can draw this curve for this Gaussian probability density function. So this whenever if you want to analyze some signal spectrum or anything, if that spectrum is look like this bell-shaped curve, so we can easily estimate using of this Gaussian probability density function. So here in that particular function, we are mark it as x and the p of x, x and the p of x. For the corresponding x, we are generating the possible values of x. So whenever that bell shaped curves are there, so that is called Gaussian probability density function. Thank you.